We treat breakthrough hardware design as if it relies on a random spark of genius, but the reality of high-level engineering is far more predictable. Welcome to the lab, Idea Mechanics. I'm your navigator. Today, we're looking at the specific engineering logic behind the devices in your pocket. Before we open the case files, subscribe and ring that notification bell. We want to hear from you in the comments. Which tech challenge should we break down next? Adopting a systematic methodology means you stop waiting for ideas to happen. You start architecting them. Modern electronics face a massive, undeniable contradiction. We want giant screens for media and productivity, but we also require a profile small enough to disappear into a pocket. For years, the industry's reliance on rigid glass substrates made this a geometric collision. You can't shrink a standard sheet of glass without breaking it. The tech industry simply accepted this. They treated bulk and fragility as the inevitable price for having a display at all. This wasn't a minor design flaw. It was a physical contradiction that required a new set of rules to solve. To solve it, we ask the targeted TRIZ question. How can we replace these rigid, bulky components with materials that can achieve impossible geometries? This is where we apply Principle 30, flexible shells and thin films. Instead of trying to manufacture slightly stronger glass, the strategy shifts. You systematically replace the rigid structure itself with bendable materials. When you remove those physical constraints, the hardware adapts to the user. The device no longer dictates how much space you need in your pocket. Moving past the current hardware plateau means abandoning the materials the industry was originally built on. The first step is removing the rigid glass substrate. In its place, engineers substituted highly adaptable thin plastic substrates. They deployed thin film transistors to control pixels, topping the stack with a flexible protective layer. The transition from a rigid slab to a folding display follows the exact blueprint of Principle 30, replacing a problematic material with a flexible shell that performs the same function. This process unlocked screens that can fold and roll without shattering. These foldable devices are the practical result of resolving that initial contradiction. We finally have massive screen size and pocketability in the same footprint. Solving this physical contradiction created a multi-billion-dollar product category that didn't exist a decade ago. Systematic innovation changes the physical state and capability of consumer devices. Hardware evolution isn't just about putting a faster processor behind the same glass. It's about rethinking the structural architecture itself. These shifts in device design are the result of repeatable architectural skills. By applying tools like Principle 30, engineers stop letting historical material limitations dictate what they can build. Take these systematic tools back to your own workspace. Look for a rigid constraint you've always accepted and see if a flexible shell can break it. I'll see you in the next session.